Hi friends, welcome to Engineering Clinic. Today we are going to see a topic on vehicular radar networks, VANETs using Ns3 and SUMO. This is what we are going to see. So we can see two examples. Now we are going to see the example number 1 and the example number 2 will be following in the next lecture. So this is what we will be seeing. So in case we want to see VANETs in using Ns2 and SUMO, you can use SUMO OpenStreetMaps and VANETs using Ns3. You can see I have already a video attached to it, so you can able to check it. This example also uses VANETs, SUMO, Ns3 and OpenStreetMaps. So these are the three things we will be using. So anyway, I will just make the editor size bigger. Okay, so what we'll be doing is we'll be seeing this exercise. So we'll be using Sumo software. So if you want to install this software, you can refer my previous video. It tells you the how to install Sumo. So Sumo version 1.2.x. so this is the version I have installed recently. And so never give this command. So don't use the following command: sudo apt install sumo-gui. Never ever use this command, because in this case you cannot use or you cannot extend the Sumo, so you cannot add any new modules or any new simulations using this. So don't use the following command. So rather than compile it from the source. So compile it from the source. So that's what I have done it. So download sumo.1.2.x something .gz, unzip it, and then you can install it. So only then you can able to use the Sumo folder, or you can use git clone. So git clone command you can use to clone the entire Sumo folder. So you can refer my previous video for installing Sumo. It's already given. So now I'll just come here. So we have a folder called Sumo here. We have folder ns all-in-one 3.29. so what I do is softwares used. So ns-3.29 Sumo version. So let me check what version I am using. Sumo, you can see this is a 1.2.0. so this is the version I have used. So 1.2.0, this is the version I have used in Sumo. And I will be using a OSM also. So that is OpenStreetMap. So this is the wizard I will be using. So we have a file called wizard, OSM wizard file there. We are going to use this. So first what I do is I'll just go inside the wizard. So cd sumo, and you can see there are so many folders. So there's a folder called as tools here. So go to tools. In the tools you can see there are so many Python files. So I am going to use osmWebWizard.py. so you can see the spelling over there. So webwizard.python file, this is the file I am going to use. So this file will enable, actually it is one of the very easiest method to generate any traffic scenario. So we can directly use this file. So what I am going to do is, in the command mode, first go to cd sumo /tools. Then after that we can use python space osmWebWizard.py. This is the command we will be typing. So you can check it now here. So python osmWebWizard.py. once you try this, it will create a new browser window. So this is a browser window, you can see that. So it automatically opens. So you can see this here. This is the file I am just opened. The index file is already opened directly, and this file shows you a map of it. So it shows the position of Berlin, a place in Germany. So what we are going to do is I'll be using my current location, or I can search something. So let me use my current location. So you have to give the browser to access your current location, and it shows me this is my current location. Okay, so instead if I go with Chennai, so the place where I live, Chennai. So when I search it, it shows you the Chennai map. So you can see Chennai Fort, you can see Anna Salai, you can see General Hospital Road, and you can see railway track, suburban track, all these things you can able to see. So I can move down to some roads where I can able to copy some roads. Yes. So what I do is I'll be using something from here. Okay, so you can see this here on the right hand side we have select the area. So select the area, so it automatically gives you the area. In case if you feel the area is very big, you can make it small, because when you increase the area to a larger extent, the complexity of the files also getting increased. So better have a smaller area. If you have huge computing power, or you have a huge computing machine, you can try to use a very bigger area, so that the file processing will be very good enough. So now this is generate scenario. I can click it. Before clicking it, I can customize my vehicles. So you can see that there is a vehicle here. So how many cars you want to make to run in the simulation, how many trucks you want to make to run the simulation, how many bus you want to run, motorcycles, bicycles, pedestrians, trams, urban trains, like this. So first what I do is I'll go with toll cars, and let me go with the bus. So when you click bus, how many counts? 4. I use motorcycles, and as well as I use trains too. So do you have any railway track here? Okay, fine, I'll stop it now here. So I'll use some pedestrians too. Okay, so now I have selected cars, bus, motorcycles, and pedestrians. Okay, so now I generate the scenario. So when I generate the scenario, just come and see here whether everything should be in correct line. Sometimes you may get some error, so you have to rectify the error. Some path error might be here. So now after it is generated, automatically the Sumo-gui gets popped out. So this is loading configuration. Then the Sumo-gui, it's opened its the Chennai map here. So this is the map here what we have taken, and now this is the delay. 20 milliseconds is a very small delay, so you cannot see constructively. So I can increase that to around 200 or 230, something like that. It's a real world, and we can run the simulation. You can see here. And you can see there will be some traffic signals too. So green, yellow, and red, there will be some traffic signal, and you can see the cars. You can see the cars as per the distance it is. So you can see I have a open bus also. So buses are waiting here for the signal, and it moves around. And here you can see again cars. So we have given some pedestrians too. Let me check it somewhere. Any pedestrian? Yeah. So again bus and cars are moving here and there. You can see more again. Still these are also cars. Okay, so what you have tried is, yes, somewhere we can see bicycles or motorbikes also. Somebody can see here there is a motorcycle, and so this is a general simulation that how we carried out into Chennai traffic. So this is the place where I live, and this is the traffic how it generates in a particular city. Okay, so this is a very longest process when you are trying this in the earlier software, the same Sumo software, but it is a very easy to handle now. So we have got the first output ready. So here you can see the number of cars here, and you can see so what is the factor. So you can see how many running vehicles, what is the average speed. So you can get the network parameter directly by clicking this link here. in the software you can see this is the link here, and here we can see the number of again the network parameter. Here you can able to check how many departed vehicles, what are the running vehicles, how many arrived vehicles, discarded vehicles. So and end time, begin time, there is no time as such because we have the simulation is still running. Okay, so you can see the check the simulation time also, I didn't show it here. So totally 3600 duration, so seconds, that means around 60 minutes, just 1 hour. So we have given a thing of 1 hour. And left hand traffic, so since I belong to Chennai, so our traffic is on the left hand traffic. So in case if you want to use right hand traffic, you can remove this, so that in US you can go with right hand traffic. So this is how the way I just do the simple scenario. It's a very easier thing to process. Now how we can incorporate this into our network simulator 3, so that is a challenge. So we'll be seeing this challenge here. So first what I do is I'll just close this window. So after I close this window and I want to use this file. Okay, so loading configuration done. So okay, so now you can see so in the same folder you can see there is a folder with the time and other things. So 1/7/2019 10:59:24, that means at this time I generate the simulation. So just open it, you can check in the files, what are the files of get created. So we have a net config file, we have net.xml, passenger trips, pedestrian, motorcycle, bus trips, and pedestrian route, pedestrian trips, and sumo config. So this file is very important for us, osm sumo config file. So we'll be seeing how to deal with this file. So we have to generate some XML files to understand in Ns3. Also we need some TCL file also to understand the mobility of the vehicles. So here in network simulator 3, what happens is the mobility of these vehicles become the mobility of the nodes. So that we'll be seeing now. Okay, so what I do is I just come to my Ns3. So I go to a folder called as, so anyway I'll just use this. So in this here I have given select the cars, buses, motorcycles. So these things I have selected, etc., and generate the scenario. Sumo-gui automatically pops up. So that's what we have done. So after that I closed it, and again I have just come back and have checked it. Now in this src we have a folder called mobility. Here we have examples. So you can see there is a folder called as, there is a file called as ns2 mobility trace. So we are using ns3 script here, but the ns3 we are going to read the mobility.tcl file. That's why we use ns2 mobility trace.cc file. I'll just open this file. So when we want to run this file has to be moved to the scratch folder. You can refer my other lectures on ns3 to know more about this. So this software, just this source code is very simple to understand. So we have IO stream, F stream, file stream, IO stream, string stream, core module, mobility module, and we have the position of the vehicle or the position of the node and the velocity of the node. So get the speed and get the position, and print the position x, position y, position z, and velocity x, y, and z. So these are the three things have been printed. We can see that this will be printed in the terminal window. And in the main function we have two files, one is trace file, another is log file, and node number and duration. So we have two things we have to specify. So how many node numbers you want to simulate, and what is the total duration of the time. So duration we have given as 1 hour, there 3600 seconds. So accordingly you can use it. Now when you come here, trace file, it is ns2 movement trace file. The node number is number of nodes, duration is duration of the log file. Okay, this is the log file. And if suppose if trace file is empty, or the node number is less than or equal to 0, or the duration is less than or equal to 0, or the log file is empty, then automatically this command will run. So waf run, this is the name of the file, trace file, src mobility, default ns movements, node number is 2, duration is 100, this will. So this only we are going to run in this simulation. And you can see ns2 mobility helper is a class already designed in ns3. We have created an object called as ns2, and we are storing it in the log file. and how many nodes we are going to create. So suppose we are creating 100 nodes, means we can create 100 nodes here in ns3 and install this ns2 mobility in all these nodes, and this mobility course change. So as per the mobility.tcl file, this data will be populated, and finally the stop, run and destroy. So this is what we are going to see. Now in this file, what I am going to do is I will just copy this file into the scratch folder. So after that I do the modification within the scratch folder. So what I do is copy ns2 scratch. So I have just copied this into the scratch folder. So in case if you feel uncomfortable in terminal, you can directly copy paste in the folder. So maybe I will do that command, so for better understanding. So what you do is you go to ns all-in-one, ns examples, then mobility, sorry, not here, src mobility examples ns2. So go to this folder, copy this. I will just right click it, copy, and then you come back to ns3.29. here we have a folder called scratch, and paste it. So this is a very simple command that I can able to do the pasting. But now my job is to create the mobility.tcl file. Okay, so I'll divide into steps. Step 1 is create the Sumo-gui or Sumo configuration file using the above steps, using the above method. Already we have done it. Number step 2 is create the mobility.tcl file. Number step 3 is run the ns2 mobility trace.xml file with node number, duration, log file, etc. Step 4, include the NetAnim code and run the simulation. So these are the 4 steps that we'll be doing. So first thing we have done it already. Step 1 is already completed. Now create the creation of step 2 now, mobility.tcl file. So how to create? So that's the task now, how to create. Okay, so this is what we are going to see now. Okay, so now what we are going to do is go to this place here. Already we have pasted here, clear. So cdns. Okay, now nothing, mobility.tcl. okay, so now what I do is I will go inside Sumo. So Sumo, then tools, then 2019. So this is the place where we got the file here. You can see this here. This is the file we want, osm.sumocfg. okay, so now what we do is command is sumo -c osm.sumocfg fcd-output trace.xml. so this file we are going to use. So what we do is whatever we generate in osm.sumocfg, we are going to send it to the output file called as trace.xml. so we are going to convert this into trace.xml. now we can see this is how it is done. Now it may take some time according to the size of the config file. Maybe I'll just open the config file. So just discard the warnings. You need not bother about the warnings, because when you are converting the real traffic into a particular simulation network, the simulation may discard some of the data. So that's why it is discarding. So you need not bother, and you should not get any error over here, but there is no error here. And you can see digigstar router. So there are so many routers files available to our router, digigstar router. So as per the digigstar router, the output is generated. Okay, so now we can check it here. So we got the trace.xml file ready. So now I open this file, osm.sumocfg. when I open this file, this is the sumocfg. so you can see net.xml file, poly.xml file, and view.xml file. so there are so many files. again when you go trace.xml file, so you can see it is taking so much time to get open. So because the number of lines you can see here, the bottom right corner here, where the mouse, the location of this mouse, you can check it here. So still it is reading. So the number of lines is very huge according to the size of the map we have taken. So I have taken a small area in Chennai, so it populates so much amount of data, almost crossing now 8 lakh. We will wait. Okay, so this is the XML file. You can see that you can go to the end of the data. Totally around 11,60,143 lines. Okay, so this is the file we got generated. Anyhow, I'll just close this file at time being. So this is the file we need it. Okay, now in this only we are going to start the mobility file also we will be creating. So what we'll be doing is, so we have a trace exporter file here. You can see trace exporter. Again we have these tools. So whenever if you use sudo apt-get install sumo, you won't get these tools, you'll be in trouble. So better use compiler source, compile with the source. Okay, so now we have traceExporter.py file here. So what you can do is python space traceExporter.py. when you run it, it generates usage I filtered optional. The output can be sample filtered. So I'll go with help file. Is there any help there? Yes, we have a help. So I'll just maximize it. So what we can see here is yes, ns2 mobility. Can see there is a ns2 mobility file. So output equal to, it will send it to some mobility file, and fcd input, yeah, fcd input here equal to this file. So the input file will be the trace.xml, and the output file will be this file. So I'll just copy this and remind this. It is I also, you can put it, or you can use fcd input. So whichever way you like, you can put it. So now what I do is -i trace.xml, but trace.xml is in this folder. So trace.xml, then this paste it, mobility.tcl, mobility.tcl. I am creating mobility.tcl under the tools folder. You just check it, in this folder I am creating. Okay, so in case we want to create in a new folder, you can create this into the same folder 2019, you can create it. Now when you try this, it creates the mobility.tcl file. So python space traceExporter.py -i, the name of the file trace.xml, and ns2 mobility output, and it will create mobility.tcl file. So we are going to create the mobility.tcl file in this folder 2019, this folder. So please maintain that folder, or if you want to store the folder, you can move it away from this tools folder and then keep it aside. Yes, now it's done. Now again I'll go inside 2019 folder, and you can see I got the trace.xml already there. I have mobility.tcl. So gedit mobility.tcl. So again this mobility.tcl will be the number of nodes. Now that's what we have done it here. What I do here is, now mobility.tcl is created. Now how to do is, first command is sumo -c osm.sumocfg space fcd-output space trace.xml. So and we'll just check it again, what command I have given here. Yes, right. So this is a command. After that what I do is, After that go to cd sumo/tools, then cd and cd sumo/tools, then python traceExporter.py space -i trace.xml mobility output equal to mobility.tcl. so this is the way that we have done it. Now we got the mobility.tcl file. Now check the number of nodes in the mobility.tcl file, which is very important, which is very important. So this is very important. So as per our file, you can see the number of nodes here. I will go to the end of it. So you can see somewhere around 1771, 1796 also there. So what I do is how to find out this node 2, node 6. So somewhere here you can set this value node underscore set is set. So this value you can find out. I can check it 1796, 1797. It's not there. Yeah, it's there. 98. It's there. 800. Still okay. Let me take up to 1800. So let this file goes any number. So let us not bother about it. 1800 I will take. 1812. And I'll go to the end of it and come back in line. So this is a very toughest task, that to find out the number of nodes, because we need to specify when we run it. Yeah, I think somewhere it's gone. Yeah, totally 1813 I think. So we'll take this as the number 1813. Have this in mind. Okay, so this is the place where we have this. Now we need only one file, is the mobility.tcl file. So what I do is I'll take this file, I'll copy this file and place it in the home folder. So this is my home. I'll just cp mobility in my home folder, home Pradeep Kumar, because I need only this file. Okay, so now I got this file. So what I do is move the mobility.tcl file into the home folder, so in my case it is /home /Pradeep Kumar. So this is a folder I am just moving it. Okay, so now what I do is step number 3. This is the file I am going to run. So what I do, the first command is cd space ns all in, assume that I am in my home now, all in one -3.29 /ns -3.29. so the program is already in the scratch folder. If it is not in the scratch folder, then network animation may not run. So always keep it in the scratch folder. So what I do is I'll just go inside this gedit scratch ns2 mobility trace. Okay, now for time being what I do is I'll just copy this command from here to here. I'll copy. I need this to run. Okay, so what I do is I'll just paste it here. So web run just so trace file equal to mobility examples. So now we have a trace file is we have home slash Pradeep Kumar slash Mobility.tcl. so now that's why we have made it, else you have to write a very big path you have to write. So node number is equal to 1813. This is a node number. Duration is, let me use 100 seconds now. Log file is I want to create a file log, keep it as it is. Okay, so this is the command. So what I do now is within double quotes I close it. I'll just copy this. I'll just paste it here. I may get some error. I'm expecting some error. I'll just tell you why that error. Okay, so I should get it because the file is in scratch folder. So what I do is scratch. So that's why. Okay, now we can check it. The file run will be smoothly, but it takes some time to get completed. So this is the simulator as I explained the source code. Inside the source code something will be printed to the terminal, the velocity and the position of the node. So that is what being printed. You can see totally 1813 nodes it will be printing. So you should not close this. Let it go. But in my previous example I have taken a small area, so it was very easy to handle, but this is a very bigger area. So if you are a PG scholar, or if you are a PG student or a MS student or MTech student, you can try out with smaller simulations. If you are a scholar, a PhD scholar or a postdoc, if you are doing some simulations, you can use the bigger area so that you have a prolonged time to handle the simulations. Still it's going. So this is the command. So I'll be doing this inside the in this folder, inside the NS 3.29 folder we have in scratch. So we'll be doing this. And now again we have to start, we have the mobility trace file, we have to edit something for the animation. I'll be showing the animation too. Step number 3 is this. Now finally the NetAnim code and run the simulation. Oh god, it's running for a long time. I'll just pause the video for time being. So you can see the simulation ends here. Okay, so you can see cat ns2 mob. So this is the file it got created. So this is a velocity, the file which is got recorded. This is how it got. So total number of nodes it will be showing you. Okay, so now that is not our task. Now we will be editing the network animation. Step number 4. So what I do here is NetAnim. I'll be creating a hash include within double quotes ns3 slash NetAnim hyphen module.h. So include this line. Step 4. So this is a very important step. So what you do is step number 4. So I'll be, whatever I'm typing here, I'll be, you can see in the documentation section of the YouTube. You can check it below the YouTube video. Below the video you can check this in the description column. Step 4, include NetAnim code. You can see I always prefer to use NS caps and AS caps as the command works that way. So include the header file and include the following line above the simulator colon run function animation interface. anim. You can use a file name called as mobility.xml. so you can use this vehicular mobility.xml. this is a file I am going to create for NetAnim, because NetAnim needs to run with the XML file. Okay, so vehicular mobility.xml. so what I do is I'll just go to the file here, go to the end of the program. Here we have simulator run, so control V here. Okay, so this is the line we have added here. The following line is added by Pradeep Kumar. Similarly here the following line is added by Pradeep Kumar. So that's what we have done. So this is a network animation module. Again we have to run the same thing again, the same file again. So again, but now this time it will create a file called as vehicular mobility.xml file it will create. So that file we needed to run the network animation. So I'll just show you how to run the animation interface. So after that, how to run the animation NetAnim, how to run NetAnim. So what you can do is you can again go to the command cd enter, then cd ns hyphen all-in-one hyphen 3.29 slash NetAnim hyphen. Okay, let it go. So you can see there's a folder called as NetAnim. This is a folder. Slash, after that you can use dot slash NetAnim. If the NetAnim is compiled, you can open it using dot slash NetAnim. A window will be opened. And select the vehicular mobility.xml file and run the simulation. So that is how we can able to do. Okay, so let's wait for some time. Once this job done, we'll execute the NetAnim. So if you want to know more about NetAnim and other softwares, you can just check my Ns3 tutorials, because I have a number of tutorials are there in my YouTube channel. You can check it. So all my YouTube channels is belonging to youtube.com/tspradeepkumar. So to get during my free time I record lectures and then publish. I give the source codes too. So please subscribe to my channel, and also you can share it to your friends. So there are so many do-it-yourself project available in my channel. Also sometimes I use my website to deliver the source code as well. I have engineering clinic too, engineeringclinic.com also. So you can refer these two websites for downloading any source codes or anything. Yeah, it's done. Okay, now you can check it. I got XML file called as vehicular mobility.xml file. Now what I do, as per the command here, I put cd enter. So when from any folder, when you put cd enter, you go to the home folder. You can see from here to here I came into home folder, cd ns cd NetAnim. Okay, so now I am in this folder, cd NetAnim. I am in this folder now. Now you can see there is a NetAnim green color file that indicates that it is installed, ./NetAnim. So this get opened. Now here when you go click here and go to the folder Ns3.29 and vehicular mobility. Now you can see, so this is the vehicular mobility, you got it. Now what I do is I just show node ID. So when you click this thing, it will hide the node ID, and when you click this, so this is the node ID. So we can maximize, zoom it to check the nodes. So these are the vehicles here. See, the nodes are very small in numbers, very small in size. So what you can do is, I'll just show you the node size. I increased to 20. You can see this is the node size. Okay, so these are the node size. Now what you do is, you can include the simulation. Now this is a simulation, so we have given totally for around 3600 seconds. So slow simulation, I increase this to fast simulation. You can see the vehicles can move here and there. You can see the vehicle is moving here. Still more faster, you can check it. So I have given only 100 seconds over there, because the duration I have given as 100 seconds. So up to 100 seconds you can see the vehicles will be moving. So here you can see the vehicles are moving. You can see the vehicles are moving. So up to 100 only it will be showing you, but even for 100 we have struggled a lot. But if you want to increase more, you can increase it. After that you can check out the trace metric software, Wireshark, and all these things you can enable for identifying the network performance. I leave it as an exercise for you to identify the network performance, because I have given the network performance in other videos. You can check it. So a very simple exercise, but it took me a long time to record. So what you can do is, you can do the network performance, like Wireshark ASCII trace metrics, using trace metric software. Then you can use GNU plot for plotting the characteristics, etc. You can try out this. So these things you can try out as a post exercise. So thanks for watching the video. We will be seeing with the second example using VANET, using Ns3. Then we will be seeing next week. Thank you. Subscribe and share. Thank you.